All right, this problem here, we're going to take a look at a problem from section 3.3. So we wanted to see solve when cosine theta equals 1/2. So first thing we can do is we can look at the graph of cosine theta, what's called cosine x, and then we could take a look at one that equals 1/2, so equals 1/5. So we can see that we're going to get infinite number of solutions because we haven't limited our domain. So let's note that if we take a look all right, the cosine theta is 1/2. So cosine theta is our x value. So it's 1/2, 2 spots, right? So there's one here and there's one here. So here you're going to have 1/2, comma, and you're going to have a positive y value, which will actually be root 3 over 2. Okay. And then here you'll also have 1/2, but you're going to have your negative y value, or negative root 3 over 2. Okay. So because the period of cosine is 2 pi, so here we have these two angles this happens. Let's call this theta 1. Let's call this theta 2. So to find those angles, we could say theta 1 is equal to the inverse cosine of 1/2. Okay, so we can see this happens at 60-degree angle, or pi over 3. Okay, but because of the period, if I add or subtract any multiple of 2 pi, so I could add or subtract any multiple of 2 pi, so I'll call it 2 pi n, or n could be any integer, so it could be 0, it could be positive or negative 1, positive or negative 2, and we're going to get a whole bunch of solutions that are differences of period of the pi over 3. The other angle, theta 2, well, that's going to be the 5 pi over 3. So we'll have theta 2 5 pi over 3. So almost a whole 2 pi around there. So that's 160-degree slice short. And then you can add any multiple of 2 pi into this as well. Okay. Again, n could be either 0, negative or positive 1, negative or positive 2. So you have two solutions, and each solution is going to have infinite number of them. So let's take a look at that graph again. So let's just note that here's the one intersection, okay, and here's the other intersection here. So your 5 pi over 3 is your 1, and your negative pi over 3, which is actually 5 pi over 3, right? So if you add 2 pi to that. So and then you can add and subtract any integer multiples of those. So you get all these solutions. Okay. All right. So I hope you found that useful.